set of data. And by using the calculator is going to come up with the function for the data. It's going to write the equation for us. What we need to be able to do is decide what will be the order of the function. Basically what that means is what's the degree. And in order to be able to do that, yes.
Is this 6.9?
It is. It's a part of 6.9. This is where I'm getting these problems from. I felt that it wasn't really needed to get into this part of the test, just because it's a lot different than what we've been working on. So I didn't think it was really needed to throw in here. This section is going to mix in some of the quadratic regression, which is the same thing, as well as polynomial. Now, your job in this section really is to just be able to tell how many changes you're going to have as far as what kind of a curve it's going to be. And it's a little bit different, as Sri can tell you, as to what we've been looking at in the past. It's a little bit different, okay? We'll probably only wind up having to do this for a day. Tomorrow we'll start the next unit, which is Chapter 9, Rational Expressions. And that starts out again with exponent rules, okay? I think it's exponent rules. It might not be. I forget what chapter that is. 9, but I don't know what it looks like. Anywho, you'll find out tomorrow. So here's what happens. In order to do this regression stuff, I have this giant how-to handout.
Look at that.
Mr. Fontana made these a year ago.
Nice.
And then we had Bounds. I think the graphics guys made these, like actually printed this stuff out last year. This is basically everything you need. I'm sick of counting.
Right.
This is basically everything you need to know how to use your calculator to make this stuff work. I've had people ask me, oh, will I be able to use this on a test? And I'm going to say, no. Yeah, you got it
Then
right.
why are we doing it?
What is this?
But here's the thing. You can keep this. Now, what's nice is that once you use this once or twice, you're not going to need it anymore. It's a really nice user guide. No, because we're going to go back to this calculator modeling again second semester. So, I don't know.
It's covered gloss.
It's covered gloss.
It's cardstock. Magno? It's cardstock. How do we ever
It's just nice to
So should we not let them?
No, you can keep it yours, whatever. If you want a whole bunch of put in your notebook, go for it. So here's what happens. I want to take, oops. It was just me and my kids. And I want to. So I want to look at this handout. So here's what we do. We're going to follow this handout pretty much verbatim as far as the example they have in there. And the first thing it says to do is to clear your lists. So in order to do that, you first have to have the calculator out. That's helpful. And now you have to hit second memory, which is the plus button. Choose option 4. Option 4 is clearing all your lists. You probably had nothing in there to begin with. It's not a big deal. We're just refreshing the computer, or the calculator. Hit enter, and it should say done. You can scroll down or hit number 4, okay? Everybody all right with that?
Yeah.
All right. Now, we're going to hit the button that says Stat. It's the one right below Delete. You should have a screen like this. You want to edit your lists. So hit Edit right now. Just hit Enter. Option number 1. And you should see lists. L1, L2, L3. You can have, I believe, up to 6 lists. We're only going to worry about 2 of them. Okay? So what I want you to do is move your cursor over to L1 And if you look on the right side of this handout, you'll see what the table should look like. Everybody see that? You want your L1. Your L1 is basically going to be your X values. Your L2 will be your Y values, your F of X. Yes, ma'am?
I don't have an
Oh, that's a problem.
Are we supposed to make it look like that?
That was pretty funny.
Well, we would
Not a
do
problem.
It's just not, it's not just me.
This will only
Read out it about today. Is it still open? Yeah, it should be.
It'll be my honor.
Everything.
So enter your values 71, 61, 66, 72, and 73. Now to go to the L2, just hit the right cursor and type in all the corresponding values.
Wait, what? Why is this working?
Shouldn't be confused. All you're doing is entering in data. It's this stuff right here. Yes, you can write food in there if you'd like.
You write
It
70.
can, you know what? It swears too. Oh, what?
You can write poo. What's making Emma blush?
I know. So, is everybody at the point now where you have that as far as your data? Okay. Here's what I want you to do. Real fast, go to your Y equals button. Press clear just in case you have an equation in there. Bless you. Now, go to your graph. You probably don't see anything. Here's why you don't see anything.
Because the windows is
Not just the window, what right now you have set up is to look at a regular Y equals screen. You don't have it to look at the stat screen. The stat screen. So here's what you do. Hit second Y equals. You notice that it's called stat plot in the...
I thought it said start plot.
start your plot.
Whatever. So you have it called stat plot. And if you look at yours right now, it probably says off. Okay. Here's what you want to do. You want to have that plot 1 on. So to do that, you hit enter. Oh, and yours does actually say the X list at L2, Y list L3.
Yeah. No.
What?
Oh, yeah.
So, hey guys, you want to make sure that it's on. So you select it to be on, and then you've got 6 basic types of graphs to look at. Scatter plots, line charts, bar graphs, box and whiskers, and some other weird things. Box and whiskers.
I've never seen that in my life.
Long time ago.
4th grade.
Now, when you get into this, you can have your data points can be plotted a couple of different ways. A square, a plus sign, or a dot. Choose your own, whatever you want. I don't care. Okay?
I did it all.
Now, once this goes, go ahead and hit graph again, and depending upon what your window is set at, you may or may not see that.
I see it.
So now, we're going to adjust our window. Since you have your data set in front of you, what is your minimum value of X that you have in your data?
0.
61. Your minimum value according to your data list is 61. So I'm going to set my X min to be at 60.
Yeah.
What's my maximum value of x? We set it for 75? Okay. Now, I don't think I've ever told you what this XSCL stands for. It's called scale. It's how much you want the x's to be going up by. You want to go by 1s, 2s, 3s, 4s, 5s, whatever. I didn't make this. Mr. Fontana made it. And what he did is that he changed the scale sometimes so it's a little bit easier to see the grouping of the numbers. He had it going by 5s in this case, just because it pulls everything in a little bit tighter. To change the x scale to 5, you can leave it at 1 if you'd like. But if you notice here, if you look at my graph down here, see how it's just changed it? It's just truncating this a little bit. Okay. Your y-min, if you're looking at your values here for y on your L2, the minimum value we have is what, 108? Set it at 100 or 105 if you want. I'll put it at 105.
Yes.
The maximum was what, 200?
Yeah.
And what I have here for the scale, I have it going by 20 instead of a bunch of little dots. So it just sees a little, you can see it a little bit cleaner.
What's X-res?
I don't know.
And triangle X?
Change in x is going to be how much you want your table to change by. Your table should change.
Why are there an X and T, a little circle with the line through the end of the X on here.
Oh, sometimes it's x, sometimes it's t, sometimes it's theta.
You can change it on the calculator.
You press graph now?
So it's just saying you can put it as X, but it's
Yeah.
just another symbol.
Oh, I found them.
So hopefully you guys got some sort of scatter plot that looks like this, right?
Yeah.
Oh, yes.
Maybe you don't have some parameters. We're not worried about bar graphs. That's why I didn't tell you. It just says you could. So here's the thing. In this example, they're wanting you to look at it and figure out what would be your line of best fit. Remember that?
No?
No.
It being a scatter plot, this is more than likely going to be a linear. This example, all right. This example is a linear example. It's a polynomial with a degree of 1. This is the only time you're going to see one like this because it's on this sheet. Everything we're doing is going to be squares, cubics, quartics. And there's fourth degree. So what this is going to do here is by pressing a couple of buttons on the calculator, assuming that it is going to be linear, it'll tell you what the equation of the line is. What's the line of best fit? Here's how you do that. You want to go back to hit the button that says stat. And we're assuming that this data is linear. Go to calculate. Move it to the right one. And now you want to look at linear regression. Option number 4. If I hit option number 4, I get this. Did yours go up with LTL? Hold your horses! Back the truck up! My operating system is different than yours. Take a deep breath.
So it's like a weighted background looks like that?
No. Just hit enter a couple times and you're fine.
Yeah, I went straight to that.
That's fine.
Okay.
Hit enter. Now, here's what this data is. Here's what this is telling you. It's telling you that the equation, this basic equation for this, is in the form of y equals ax plus b. It's telling you what the coefficient of a is, saying it's y equals 6.18 times x minus 270.81. That would be the line of best fit to that data. Yes, ma'am.
The O is definitely an error. You're my calculator.
If you bond a better relationship with your colleagues. No,
That's strong.
I don't know. I will figure that out. It depends on how bad the equation is. So let's do this now with a different example. And what happens with these other ones is the following. I want to show you the difference. Oops. I'm going to work off this table, sir. No, and depending upon the problem, you don't really need to. The homework problems you're going to have tonight, your L1's going to be 1 through 6, except for the last one. Okay. You clear it out, it'll take a second to do that. Okay. So here's what I want to do. I want to write the equation of the data that matches this. Okay. The easiest way to do that is to remember one of two. Well, remember these simple steps. X is L1, f of x is L2. X gives you a y. Okay? Those are your two lists. So the first thing you want to do then is, if you want, clear out your lists, which isn't a bad idea. Remember, clear your lists. Remember to clear a list. Second quit, I'll hit second plus number 4 and hit enter. Very fast to do. Plus 4. Now to go into editing the list. Did you get that okay to clear it? Second plus. Oh, sorry, I'm moving around here. So I'm going to go ahead and do my list by hitting stat. Hit edit, and I want to enter in my values for list 1 and list 2. List 1 was 1, 2, 3, 4, 5, 6. Okay. List 2 was it -4, 0, 21?
26.
Oh, 26, 48.
76.
Thank you. Okay. Once you get these, I want to show you two things that's happening.
Wait, what's 4?
26.
Alright, thank you.
Could you go ahead and adjust your window to get a visual in your calculator of what this looks like?
Oh, yeah.
Play around with the window. It takes some time to doing that, and you got to change the window each and every time. Couldn't I just rough sketch this?
Yeah.
Here's why I want to do that. Rough sketch it. If I'm looking at my data sets, my X values are all positive. Do you agree? My Y values are positive and negative, which means what two quadrants am I looking at this graph to be in, according to the data that I have right now?
Quadrant 4.
1 and 4. I know that this, according to the data, these points will be plotted between quadrants 1 and 4. We okay with that?
Yep. Yep.
I'm not marking off any tick marks. I'm not walking through anything. All I know is that if I start at 1, I'm at -4. At 2, I'm at 0. At 3, I'm at 10, 40, 26, 48. So I'm increasing quickly. Everybody see that? This isn't linear. You see how it's increasing quickly? It's curving.
Oh, it's on a bad thing.
Okay, it's curving upward.
That thing.
Now, I want to show you real fast the difference between an increasing quick curve up versus a hook curve up. When I'm looking at it increasing quickly, it looks like it's 1/2 of a parabola. Do you agree?
Yes.
A parabola is what degree? It's a squared degree. Now, if I look at a hook one, it also kind of looks like that though, doesn't it?
Yeah.
Yeah, and that's where this gets a little bit weird. When you're looking at, assuming which degree that you're looking at, single curve up is more often you're going to be a squared term. You're only seeing one direction. You're seeing one direction on a graph.
Hey.
Couldn't pick them out if I give you cake. Now, if I'm looking at one that has a hook and doing that, that's more than likely going to be a cube. Now, in your mind, you're thinking, well, an x squared term has one change of direction, right? This is only one direction, though. An x cubed function has two changes of direction. This really only has one change of direction here, though, doesn't it? A fourth degree, if you rough sketch it with these things, would do that, wouldn't it?
Yeah.
And that would be a fourth degree. Now, in your mind, you'd be thinking, all right, I'm looking for three changes of direction. Here I only see two of them. Here I'm looking for two changes of direction, and I only see one, and so on. It's counterintuitive to what you guys have done in the past with the graphing and all the other things we've looked at. Because you're only looking at a singular part of the function. A smidge, yes. You're only looking at a portion of it. But if you remember in your mind that these generic rules tend to hold true, you're going to be fine. Okay? So if I go back to this curve here, it looks like it's just increasing quickly. What degree should it be then? Should be a second degree. I should be looking at a cubic. So now my third step is to use my calculator. Now, did I say cubic for a second degree? I meant quadratic. I apologize. So I go to my data. I've entered in my data for this set. I'm going to automatically just hit second quit, get out of that screen. I'm going to hit stats again. I just cleared out of the screen. I said second quit just to go to refresh. If I hit stat, now I pick quadratic. Oh, excuse me, hit calculate, then hit quadratic, number 5. Yours might look a little different. Hit enter a couple times. You should get that.
I did not.
Calculate.
Wait, calculate.
No,
Yeah, 5.
Can you just like go over this like
I got it.
5. Why do you put 5
It's a quadrant.
I'm going back to a clear screen. You have your lists in, right, Olivia?
Yes.
Okay. From the clear screen, I'm going to go to stat. Move over one spot to calculate. We've decided this is going to be a quadratic regression. So I choose quadratic regression, option 5. And then I said enter a few times.
Quadratic plus t squared.
Yeah. And it's doing this, it's calculating what is the curve that has those points. And it comes up with the coefficients here.
oh my goodness.
So it's writing in terms of ax squared bx plus c, where a is 3, b is negative 5, and c is negative 2. Therefore, your equation is y equals 3x squared minus 5x minus 2.
Oh.
Because you use linear regression, not quadratic regression.
Okay, where's the
Are we back to use y now? It's 1-4.
Y f of x, either one of them is the same. Yes, ma'am. Yeah, we're using all these problems. They're either going to be quadratic, so either going to be second, third, or fourth degree polynomials. Okay. I won't give you anything that's going to be linear. Okay.
On the homework, are you going to expect us to write just to write down this?
All you have to do is write out the equation, because a lot of this is all calculator based.
Ah.
All right.
So you're going to expect us to do a rough sketch, though?
It's helpful that way you know which direction it's going, but you might pick up on this. Yeah, again, what do you got?
I put that equation into the y equals section. It looks really similar. It has
should.
2 changes.
Yeah, it should.
Actually, then it has
Huh? It should. So try this one now. Oop.
Rough sketch.
Now, same basic, I'll just move this out of the way here so we already talked about this here. Now, as you start to get better at this, you may or may not need to do the rough sketch. That's what Zach was getting at here. If I'm looking at this, it's going down, goes up, it goes up. So it's got the hook to it, doesn't it? It goes down, it comes back up. What degree is this going to wind up being? X cubed. It's going down, then comes up. If it was 4th degree, it would go down, come up, then go down again. Or go up, go down. And have those shifts. So if you wanted to go back and rough sketch to understand what is it going to look like, it works its way down, comes back up, and goes. So it's that hook. When I see that hook like that, I'm going to automatically go with a cubic function. I enter in my lists. You guys are asking if you have to clear out your lists all the time. Notice that I'm going 1 through 6 here in this example. I don't really need to clear that bless you. I don't have to clear out L1. Bless you. I can overwrite. Oops. If I go to my stat and hit edit, I can overwrite L2 just by typing in new numbers. It was -1, -4. Back to stat. -3, 8.
You're gonna have to apply some things.
So we press 6 for cubic.
Yeah. So your list for L2 should look like that. -1, -4, -3, 8, 35, 84. And then when you go back to your stat, you just hit stat again, calculate, and we're looking for a cubic, so it would be option number 6. And those are your leading term coefficients of the
X
degree of
squared minus
confidence.
4x squared plus 2.
So it's x cubed.
X cubed
So you want to
minus
get
4x squared.
minus 4x
plus
squared?
2.
Yeah. Pretty slick, isn't it?
Yes.
Can't believe it took a while to learn.
It's pretty slick. It's completely different than what we were working on. That's kind of why there was really no barrier to put this into that test before, because it's different. Yes, ma'am.
Wait, so there's one on the mark where it goes down and then up and then up and then up again. Is that one fourth or?
It should be 4th degree, yeah. I don't think there's anything more than a 4th degree. It's only 2nd, 3rd, or 4th degree.
Okay, so down.
Yeah, because I don't think this does a 5th degree. Won't do. I don't think this
Well, no,
does.
I
5th.
just didn't know if it was like second.
Oh, yeah.
We say that it doesn't get harder.
Yes, sir.
Is an X squared called quad in the calculation?
Yeah, x squared is quadratic. Yep. Questions about that? Not bad, is it?
Please say that it doesn't get harder than this.
Well, you have to interpret it, but we'll eventually have to do some interpretation. But more often than not, it's table stuff, and it's relatively easy.
Good. All right.
So through these, it's so this is section 6.9.
Wait, all of them are even?